Alright, so this is properties of logarithm continued. This is the back side of the note sheet. These are puzzle problems. These are puzzle problems. These are to be, this is just manipulating the logarithms. If you ask me what is this used for, I'm going to say, I don't know. Alright.
The hallway puzzles?
Yeah, sure, hallway puzzles. Alright, now, so there are some rules here. This is a very basic rule, and we'll be using both of these even though it's not listed. And I'll talk about what we're talking about in a second. So, when it says log base x, that means the base does not matter, right? It has to be a legal base, but anyway, base does not matter. And if that number is a 1, it's always 0. So over here, I have log base 5 of 1. It's 0. Okay? So when it says here in this formula, log base x, it means x doesn't matter what x is, as long as it's relatively legal. Meaning, I'm not going to give you problems like -5 down there, okay? Not that you can't do it, but it gets really messy when that number is negative. But generally speaking, our numbers are any positive numbers bigger than 1. Or a fraction between 0 and 1. Alright, here, this is when the base and the argument is the same. When these two numbers are the same, the value is 1. So I have log base 5 of 5, it's equal to 1. So if these two numbers are the same, it's equal to 1. Alright, now, so here's how the puzzle begins. Okay, so I have a base 8. They have to be all the same for these problems. But what's not listed here is log base 8 of 1, that's 0. And log base 8 of 8 is 1. So these two will never be listed, but they will be usable. These two will never be listed, but they will be your options. Now, most of the time we don't use these, okay? But it could come up. If like none of these working, then you should be looking for one of these two. Okay? Like I think this one gets used in this list of examples. So notice, I'm using these three values for all of these problems. Okay? So what makes it a puzzle part? So here, I have log base 8 of 66. So I have to rewrite this as a combination of these numbers I have over here, 6, 11, and 10. So what's 66 as a combination of 6, 11, or 10?
6 and 11.
6 and 11. Well, what's the operation between them? 6 times 11. So these two are equivalent. Log base 8 of 66 equals log base 8 of 6 times 11. And using the property of logs, what is that equal to?
6 plus 11.
6 plus log base 8 of 11. Okay? Now, here's the next step. Now that I have exactly what I have over here, log base 8 is 6, that's 0.9. And 11 is 1.2. So I just add those two. And I get, what is that? What is that? 12.1?
Is that 11.2?
1.2.
Oh, I copied it wrong. 1.2. No wonder it didn't look right. All right. So 1.2 plus 0.9 is 2.1. All right, ready for the next example? All right, so I have a 10 and 11, and I already have a 10 and 11. So what I'm going to do is write that as a subtraction. So it's log base 8 of 10 minus log base 8 of 11. But what's log base 8 of 10? 1.1, right? We're just given that over here. And log base 8 of 11 is 1.2. So we just do minus 1.2, which is negative 0.1.
Where'd the 1.2 come from?
Over here.
I don't know what you're doing.
Okay. Alright, so I rewrote log base 8 of 10 over 11 as log base 8 of 10 minus log base 8 of 11. You understand that? Fraction turns into subtraction. And then I look over here, log base 8 of 10 is over here as 1.1. So I replace the log base 8 of 10 with 1.1. Log base 8 of 11 is over here as 1.2. So I replace that with 1.2. And then I just do the subtraction.
So it has to be the 10 first and then
Right, so whatever combination you use, it's got to use these numbers. 6, 11, 10, 1, and 8.
Now I was saying in the subtraction problem, you got to do like the 10 first and the 11 because the 11's in the denominator.
Right. Alright, ready for the next example.
Is that one 0.9 something, the minus something?
Not minus.
It's 6 and
or
6.
plus something.
Yeah.
6 and 6.
Can you skip all the steps?
Okay, if I skip all the steps, I get 1.8. Is that what you got?
No, I was just saying. I feel like you would use 6 because or 30. I mean, yeah, 6 because none of the other numbers can't go to 36.
Okay, good. That's a good idea.
It would be
So
6
what is
times
it?
6
What is it? It's log base 8 of 6. What?
plus 6 times 6.
6 times 6. Okay, 6 times 6 works.
Then it would
So
be
that can be written as log base 8 of 6 plus log base 8 of 6. So remember, multiplication can be written as addition. So log base 8 of 6 is 0.9. So you're given that value, 0.9.
You,
So it's 0.9 plus 0.9
is 1.8.
okay.
is 1.8. And that's how I got 1.8.
So you can use it twice.
You can use it as many times as you need. Like some of these, you might have to use it like 5 times.
Once.
You can do all these laws in your head.
What do you mean?
Like you can do them in your head.
Like change this to this?
No, like can you do the next one you're about to do in your head? Right now.
Okay. I'm getting negative 2.2.
Oh, you're a little smart, Mr. Schweitzer.
No, we already did this.
Yeah, but
First.
I might be wrong.
You just remembered.
Yeah, but I might be wrong. Alright. Mental math is okay, but it's not reliable. Alright. So this can be written as log base 8 of 1 minus log base 8 of 100. Right? All I just used was the 1. Okay? And what is this value? 0. Minus, log base 8 of 100. How can I write that?
10.
10. Log base 8 of 10. And how do you want me to write the 10? 10 times 10?
Yeah.
Alright. Now, be careful here. When I rewrite this, this is going to be negative log base 8 of 10. And then another negative log base 8 of 10. Like usually multiplication is addition, right? But there's a negative sign in front, so it has to distribute to both of them. So even though it's normally a plus, because of this negative in the front, it becomes a negative here.
Oh, okay.
What's log base 8 of 10? So over here, log base 8 of 10 is 1.1. So it's negative 1.1 minus 1.1, which is negative 2.2.
Why didn't you keep the log base 8 of 1?
Because log base 8 of 1 is 0. 0 minus something is that something. Right? You don't need to keep a 0 around for addition and subtraction.
Yeah, me too.
So you just changed the same thing other ways?
Well, what's 0 plus 2? Right, the 0 is gone. 0 gets used up. You don't have to keep copying it.
Yeah, whenever oh, that's all I need.
Don't keep bruising.
Sorry.
Don't keep bruising.
No, he's looking at me.
I'm hungry, but all I have is I
Like,
got a
whenever.
Twinkie, but it got smushed a little bit, and I don't really like Twinkies. They're too sweet. And I got a moon cake.
Looks like you have plenty of food.
But Twinkies are too
Oh, yeah.
sweet.
Alright. Okay, let's go on to 480. So, what can I do to rewrite 480?
48 times 10.
48 times 10, that's good. 48 times 10. Alright, so I have a 10, but I don't have a 48 over here on the left list. So how can I rewrite 48?
8 times 6.
8 times 6 or 6 times 8. Either one is good. So now I can rewrite all of that as addition. So that's log base 8 of 8 plus log base 8 of 6 plus log base 8 of 10.
My bad, can you?
So fast.
Wait, look, 8, 8.
Like, whenever I went on a trip.
Wait, so then what
like,
did that mean? Yeah, that's
shampoo
fine.
question.
Do we have to write
Yeah,
it out
question
at
mark.
the beginning?
So, and like, whenever I went somewhere.
Okay,
else,
so the question is, do we have to write every little step? And my answer is no. If you see the pattern, you see the combination, you go straight to the combination.
And then 8 of is 1.
Log base 8 of 8 is 1. That's 1. That's not listed, but you're supposed to know, right? This one here, log base 8 of 8. You're supposed to know that one. It's not going to be listed with the 3.
Wait, is it anything with the same numbers or just 8 and 8?
Anything with the same number is going to be 1. So log base 8 of 6 is given is 0.9.
And plus 0.1.
1.1. All right, and what's that?
That's
Huh? 3.
Did you know that one in your head?
I
Did
don't
you ever
know.
get there early?
Why do you want me to do things in my head?
I just,
Like 17.
to test
I don't
your
know.
smartness.
Like, I was just asking if you could just like look at one and be like, no, I wasn't even talking about the whole problem, just like log 8, or if you knew what that was right off the top of your
Oh,
head.
no, I don't know.
Girls don't cry.
I'm going to school.
I didn't know if you just knew it after so long.
All right, let's go through example 4.
I'm crying every night.
Notice on this example, you have A, B, and C. You're not given decimal values, but you're still expected to know log base 7 of 7 is 1, and log base 7 of 1 is 0. So even though you have letters for these other ones, you will still have these available to you.
How do you know? to
But
use
they're
those?
not going to list them for you. Go ahead.
How do you know to use those if they don't list them?
Because this is a known fact you're supposed to know. Right? That this is always true of any set of bases.
Yeah, you're supposed to memorize that.
Yeah, you're supposed to just memorize that, as Milan said. Alright, ready?
25.
Alright, 25. 20, can I rewrite 25 or something?
5 and 5.
Okay, in fact, some of you, because we haven't done this, I'm going to just do it for you, okay? So, 25 can be written as 5 squared, right? So that means I can rewrite this as log base 7 of 5 squared minus log base 7 of 11. And what do I do with exponents?
Put
Put them in the front.
Put them in the front. So it's 2 log base 7 of 5 minus log base 7 of 11. By the way, no, remember someone said you have to show every step. If you skip any of these steps, that's perfectly fine. Some mental math here is okay. So I think I would have gone from here to here, this one. Right? Because I know 25 is 5 squared, so bring the 2 over, and then just put that on the bottom. So I think I would be comfortable going to this step. Now, what is log base 7 of 5? Over here, it is B. And log base 7 of 11 is C. So all I do is replace it, so it's 2B minus C. And that's the answer. Yes.
Minus 3.
Can you go back to the little column?
Column,
Like on the other side?
the left side.
Yeah.
Alright, ready? Okay, we have 4 examples left. So here, log base 7 of 21. Okay, so, go ahead. No, go ahead. What were you going to say?
7 and 3.
7 and 3, right? So log base 7, log base 7 of 21 is 7 times 3. Right? You can use 7 because that's the base. Even though it's not listed over here, because it's the base, you can list it.
1.
Right? Which is, so that's going to be log base 7 of 7 plus log base 7 of 3. And as Luke said, log base 7 of 7 is 1.
There you go.
And then log base 7 of 3 is one of the given ones. So it's 1 plus A. And that's the answer. Yes, ma'am.
So, word doesn't matter, right?
Or, so if you have A plus 1, that is perfectly fine.
Yeah.
So like the long
Hey, Brady, might need to know this for what you're gonna do when you get older.
Huh? If you have log base 7 of 3 times 7, that's okay.
And they can only be like 5.
Ooh, okay.
5 cubes.
Alright. Someone just said 125 is 5 to the 3rd. Right? Since you have an exponent, you just bring it forward, log base 7 of 5. All I did was bring the 3 forward. And log base 7 of 5 is B. So that is 3B.
Would you not
Final
do
answer.
5 times 5?
you can put 5 times 5 times 5. So then it'll be b plus b plus b, which will again be 3b. So you'll still get the same answer if you go the other way.
121.
Right? What's 121? That can be written as a power.
I don't know.
11 squared. 121 is 11 squared.
Okay.
But what about the 9?
That's 3 squared. That's
Huh?
3 squared.
That's 3 squared.
Can
So I'm
you do
gonna-
anything with that answer?
Can I do what?
Like, can you use that for anything in,
1 plus 8 or 3b? You can't get anything out of that, right?
I don't understand the question.
like, it's not gonna help you in life.
Okay.
Yeah, kind of. That's what I was.
Well, didn't I say at the beginning, if you ask me that question about this, and I'm going to say, I do know. Although I just thought of something. All right, so here's the thing. So, it's not current, but do you know what a slide ruler is?
Yes.
Slide ruler?
Slide rule. Slide rule. Slide rule was something they used before calculators were around,
Oh wow.
right? And that was a logarithmic scale. Okay? Although that might not be accurate.
Was it like a little piece of paper you pull out of a envelope?
No, it was like a ruler,
Oh.
and there was a slide on top of the ruler. And you match coordinates to do calculations. But I might be wrong. Alright, let's just continue with this. Log base 7 of 9 minus log base 7 of 121.
I skipped that.
Okay,
7.
I forgot that we said 9 was 3 squared and 121 was 11 squared. Alright. Okay, so if you skip that step, that's great. So that's 2 log base 7 of 3 minus 2 log base 7 of 11. Alright, what was log base 7 of 3? A. What is log base 7 of 11?
C.
Which way do you want me to go?
Let's just see. Oh wait, I mean minus.
Yeah, that way.
This way?
Alright, stop.
Hey.
But like, my question was like, once you get 2a minus 2c, will at some point we do something with that answer? Or no, we'll always leave
Well, us, we won't do anything.
it? Like,
That's the answer.
calculus, do anything with it?
Okay? Alright, so this idea
Oh god.
of using a variable to represent a value
If it's complicated.
is actually it's pretty normal.
Okay,
No, no.
go back
I was
over.
answering your question.
You go back over.
I know, but I feel like it might confuse me if you,
Okay,
you get
okay,
too
okay.
in depth.
Okay.
Or
Alright, ready for the last example?
Just wait this
Or
smart
in-
can.
Thanks.
Does it ever get boring teaching the same thing 3 times a day?
5 times.
Okay, you should see me 7th period.
I see. I see.
Next year, I only have 2 sections in it,
Really?
so I won't be so bored. Alright,
5 and 11.
5 and 11, thank you. So let's do this. Log base 7 of 1 minus log base 7 of 5 times 11. And what is log base 7 of 1?
0.
0. 0 minus. So here, there's a minus sign here. So whatever that comes out of this gets that minus sign applied to it. So let me do the parentheses first. Log base 7 of 5 plus log base 7 of 11. So you see why the minus sign carries. Right? Because that's what that is. Log base 7 of 5 times 11 is log base 7 of 5 plus log base 7 of 11. Distribute that minus sign. So it's minus log base 7 of
B minus
5
C.
minus log. Very good. What was it?
B minus C.
B minus, or it's negative B minus C.
Oh.
What was the question?
Is that negative log?
Yes, negative log.
Minus C. Nothing happens to 0, it goes away.
Right, 0 goes away.
That's crazy.
Seven to nine.
And that's the end of the lesson.